This video is brought to you by Sporlan, quality, integrity, and tradition. We've got a call on a reach-in cooler that is giving them issues intermittently temping high. So we need to figure out what's going on here. It looks like it's okay right now, but we're going to dive into this guy. One of the important things that we're going to do before I work on this, we're going to get rid of the cutting boards, because cutting boards are a sanitary surface. I prefer not to set tools and things on cutting boards. If you are going to have to do that, set it on the stainless steel that can be cleaned and sanitized properly. This is an R290 system. So with R290, what I'm actually going to do is get the bottom to call. Very common to have refrigerant leaks in them, and we're going to do a quick leak search on it. These things have minimal refrigerant charge. So we're gonna look for that first real quick. So I got the bottom to call. So now that the bottom's on and the top's on, both of them have the refrigeration icon, we're gonna turn the entire unit off, because that way the pressures are open. Are on both sides. We'll let it sit for a minute, and then we'll do a leak search on the entire system. As usual, the hot spots on these are condensate heaters and evaporators. Now, let's see what we got in here. Just always, yeah, already, right off the bat. Very common to have refrigerant leaks on these guys. So we're gonna open this guy up and figure out if it's the evaporator or the TXV. If it's the TXV, I have one on me. So sprayed some Big Blue on there. When we spray it on, you wanna make sure you spray it on with a steady stream, so that way it doesn't create any bubbles. And there we go. Very commonplace. We actually stock these TXVs in our truck because they're always leaking. And being that it's copper coated stainless on the inside, I'm not going to try to braze that. We're just going to change the TXV. So we're going to sand this guy up, get rid of the charge, and then replace the TXV in the dryer and go from there. Unfortunately, I leak checked the evaporator too. I'm not picking anything up in the evaporator, but being that this is such a small system and the leak is so close to the evaporator, it's hard to tell if there's a leak in the evap too, because the whole area is just concentrated with refrigerant. So we're just gonna hope and pray that the TXV is the only leak. All right, we've worked on this box before. We put a compressor in it not too long ago, and I advised my service technician to leave the service ports on, because we're not going to be taking those off anymore on regular customers. So we already have active service ports, we don't need to add them. So we're going to go ahead and vent the charge safely. There's making sure that nothing flammable is in the area, and just we'll run the leak detector while we're doing it. So we'll get that knocked out real quick. All right, so we turned on their exhaust fans, so we're pulling air out of the building. We've got the hose right here, and we're gonna slowly vent it. We have the leak detector running. Whenever it starts going crazy, we slow down, we let it dissipate, then we continue. Okay, so give it a minute. We don't want to fill the area with combustible gases. Now granted, see there, that is a little bit lower, so we're going to slow it down and then just go a little bit at a time and just continue. You know, as it slows down, then we'll let out a little bit more. This is what you have to do when you're in an enclosed space. We're inside the restaurant, so we did our best to turn on the exhaust fans and try to move the air as much as possible. All right, we're pretty much done. We're out of gas, so we're going to go get some nitrogen, start purging nitrogen through. We're going to sand up the TXV, get it brazed in. Now this is a stainless TXV that's copper coated on the inside, so the brazing process is a little bit different. It's a little interesting the way you do it. And then we'll have to change the dryer too, but we got to sweep the system with nitrogen first. Got some nitrogen flowing through, sweeping the system out. I have the solenoid valves on right now. We're getting the TXV sensing bulb out. I've got this little thumb screw for getting these 1/4 inch things that are tight. So, and then we'll slide that out. And we got a new TXV and dryer right in here. Now I don't always stock these, but I happen to have some right now. So okay, notice the TXV is stainless steel, but it's got a copper coating inside. All right, they do some sort of fancy voodoo magic plating or something to get that. It's pretty common, a lot of people do that. So the brazing process is a little different. What you end up doing is heating the outside metal, putting the solder on that, and then drawing the flame into here, and it sucks the solder onto the inside. It's a little different, and there's really not much protection you can do on these TXVs, but because they're so small. Getting like the heat blocking compound or an actual wet towel around this is almost impossible without it compromising your braze joint. All right, what we're gonna do, come over here, heat this guy, and pull this out. Might be a little bit of a flame out, it's okay. There we go, not bad. That tricky one. Now we need to get this guy to go into here, which is a trick. Alright, it's kind of a pain in the butt. We'll clean it all up and organize it, but we're cooling the TXV right now. When you're having to deal with sensitive components, I don't care what they say in brazing school, you gotta cool that guy off ASAP. So it's cooling off, we'll inspect the braze joints and then get onto the dryer. Okay, we've got the dryer installed. With the dryer installed, it was a little bit of a pain, but it's not the prettiest thing. We're gonna do a pressure test with nitrogen, and then once we pass the pressure test, we'll insulate the sensing bulb and put all the side panels on. All right, we're setting up for a pressure test. We're just using our normal gauges. My vacuum rig's kind of jacked right now, so we're gonna go ahead and pull the evacuation through the Schraders too with my normal gauges. I gotta get new core removal tools from the last repair. But pressure test right now. We're looking at the pressure setting right there, and it says 172 PSI is the maximum low side pressure. So we're gonna go ahead and make sure we don't go above that. We'll go 150-ish. And we're just kind of put a little gas. Now we have the high and the low opened up because I had to shut the system off so the compressor wouldn't turn on. So now, we're not gonna hit start yet because you gotta let the system pressure stabilize out. They're gonna drop a little bit, that's normal. So we gotta let it sit there for about a minute or two, make sure they stabilize out, then we'll hit start on the pressure test. All right, we're at about 165 PSI. I went ahead and put Big Blue all over all the joints. We're gonna give it a minute, see if any bubbles pop up and see if we have a significant pressure change. I don't think we will, so we're just gonna start wrapping everything up. This is a warranty job, so I gotta save those parts and return them back to the manufacturer. Everything's looking good. I'm not seeing any bubbles, so we're gonna go ahead and get the evacuation started. We're ready to charge this guy. We've already purged it to here. We're looking for 150 grams. Yeah, 150 grams of R290. So go ahead and put it in on the high side, but we gotta turn the system off because we don't want the compressor to turn on. So there we go. And we'll just watch it as it's climbing, see what it'll take. We'll probably have to turn the system on too, eventually. All right, so we're doing a quick charge on this guy. I don't have evaporator fan motors in here, so we're only gonna run it for a minute. But I switched it over to the low side. We're getting up to 150 grams. We're gonna go just a little bit over so that way it compensates for all the stuff we're gonna lose when we take the gauges off. You always, on these guys, just go a hair over. I'll go to 160 grams, there we go. Okay, so we've got all the gas in there. Now it's open on low and high, or we've got gas on both sides. We're gonna go ahead and do a leak search on the thing again too, just to be safe. We're having some hard times with the evacuation on this guy. It didn't really hold as good as I like it to, but it passed the pressure test. So I'm thinking it was just because I was pulling through the gauges, but we're doing a quick leak search. Being careful, this evaporator's a little bit wet and water's dripping down, so we don't want that to contaminate the leak detector. But just running the leak detector underneath it. Earlier when I did my first initial leak search, I kind of picked something up pointing into the evaporator, but I was thinking it was from the active leak on the TXV, which it looks like it was, because we're not picking anything up in here. And then we're gonna go over here, give it a quick little search around where we brazed over here. Nothing, nothing. We had changed a compressor on this a while back. We're gonna check all the compressor connections. There's no condensate heater on this one. Not seeing anything. So I think we're good. Yeah, we're good. Okay. I really need to fix wherever my leaks are and really dig into that. All right, this guy is coming down in temperature right now. It's about 40 degrees in the box. This thing takes a second to catch up, but we'll make sure that it is accurate when it comes down to temp. So pressures aren't scaring me. Everything's looking good. Evaporator fan motors are all running in there, so we're just waiting for it to come down to temp, and we're kind of cleaning up all of our messes now. Unit is satisfied down to temp. The last thing we got to do is get the drain hose right there routed into the drain pan underneath the compressor. Other than that, everything's good. Caps are on, no leaks. We're gonna hand it back to the customer. I kind of lost a little bit of footage on this one. I lost some footage when I was brazing in the dryer for some reason, because I don't usually use a GoPro. And usually I film on my phone, so I was switching between my phone and the GoPro, and for some reason I didn't hit the record button, but regardless. So I didn't catch the evacuation stuff and or installing the dryer. The dryers on these are always a chore. And let me preface this too. When I'm doing warranty repair, you have to use OEM parts 100%. Anytime you're working on these R290 coolers, I highly suggest you only use OEM parts. So just because, you know, the dryers and the TXV aren't the ones that I usually like to use, but it's OEM only on these R290 things because I don't want the liability. So now with the evacuation, so I've been kind of having a hard time with my my vacuum core removal tools. They've been giving me trouble lately. And actually this video was from a while back, so they were giving me trouble back then. I've since replaced them all. But yeah, I was having a huge issue with them. Actually, you know what? And what I haven't replaced is my high flow Schrader depressors, because there's those little tools that depress the high flow Schraders, and I need to replace those because those are leaking too, now that I remember that. As we're coming into the cooling season, it's January 26th, but here in Southern California, about April, we'll start really kicking on warming up, and I'll be doing a lot of AC repairs, so I need to get those high flow Schrader depressors fixed, because on the we'll talk about that later, but anyways, I get off on tangents on this stuff. So the evacuation on this one, I was pulling through my manifold gauge set. Understand something: when you're pulling through a manifold gauge set, you need to realize there's limitations. So the manifold gauge set is going to have a massive pull, right, from the vacuum pump, but it's not going to be transferring to the system as fast as the gauges are saying, right? So if this makes sense, the gauge hoses are depressing Schraders, right? And those Schraders barely let anything through them. But the vacuum pump is pulling, and it's pulling right on that micron sensor inside your manifold gauge set. So it's going to read a lot lower than it truly is in the system. If you want to know if the system is you know, the same as your micron gauge, what you need to do is close off the vacuum pump hose, right? Close the process port and just leave the high and the low side on your gauges open and let the system stabilize out, and just watch your vacuum raise really high, and it'll eventually stabilize out. But you just have to understand that you really want your micron gauge to be the furthest away from the vacuum pump. And when you're using a manifold gauge set, while I do use them occasionally, you have to understand the limitations. Just because it says 200 microns on the manifold gauge set doesn't necessarily mean that's what it is in the system. Okay, so just understand that. And again, I'm not saying I never use a manifold gauge set. No, and I think everybody should have a manifold gauge set too. I still use, you know, true blue hoses and all the big fancy stuff, but I still have the manifold gauge set for these smaller systems when I want to work on them. So I wasn't super happy with the vacuum. It was taking a really long time. We went to lunch and stuff, and it just took probably like an hour and a half to pull that little system down, but you have to understand that it's pulling through the Schraders, so that's why. So it took a while. I wasn't super happy with it, but I still wanted to do a leak search on it too, just to be 100% sure. Obviously, we didn't see any leaks, so we got the system back up and running. Now, for those of you that don't know this, I'm sure your company has explained it to you. When you're doing warranty work, first off, the companies that pay for the warranty repairs, they only pay so much money. They don't reimburse you for your full actual invoice amount at your full hourly rate. Okay, so keep that in mind. Second thing is always save the parts. Here's how I do it. I always save parts no matter what, okay? Because weird stuff happens. Sometimes you lose warranty parts. Like, again, this is something that I run into as a business owner. I'll have a technician doing a job and he'll accidentally throw away the parts that I needed for warranty reimbursement. You know, it's like, dude, how do I get reimbursed now? You know, so I try to save a lot of the parts from the units that we work on, just in case we run into that situation where something gets thrown away. Then I can go grab a dryer out of my pile or something like that. You know what I'm saying? So never advocating for ripping anybody off or anything like that. I would never do anything like that. But I always have extra parts, and I save them just to be safe, because there's nothing worse than accidentally throwing away something, because then you don't get reimbursed at all. You know, that's a problem. So understand the evacuation. It's so important. And it's also so important for us to understand the sequence of operation in our systems. Okay, how they work, what happens, what this does. Okay. Last thing I wanted to talk about was the copper coated stainless steel fittings. So a couple different manufacturers will do that. Even on air conditioning systems, you know, the suction service valves on like residential systems and stuff, those are actually copper coated brass fittings. So you always want to understand that when you have a copper coated fitting, you can heat it up so much that the copper will flake off, and then normal Silphos won't stick to it properly. Now, on these stainless steel valves that have copper coating on them, they're meant to use 15% Silphos. But if you overheat it and the copper coating comes off, 15% Silphos will no longer stick to that stainless steel. You need to use a high silver content solder. Like I use 56% silver. I go way high, right? But in order to use that, you got to use silver solder flux, and it's just kind of a pain in the butt. So just be cautious and have everything ready. Make sure everything is super clean. Make sure the valve is clean. Make sure the pipe that's going into it is clean. Do as much prep as you can, and understand that when you're heating these valves up, there's different ways of doing it, okay? It's not a normal heat the joint and draw the solder into it. That's not how you do it on these things. You heat away from it, put the solder right next to it, and then just kind of wave your torch across it and draw that solder in, because you don't want to overheat it. If you point your torch at that valve and it turns cherry red, you're borderline of getting it too hot. So you want to be very careful about that stuff, okay? And what you guys did see too, if you caught it, the nitrogen for some reason wasn't flowing through the system properly. So when I first started to sweat in the new valve, you'll see it pop, and that was actually a nitrogen bubble blowing the solder out. So I had to go and turn the nitrogen off, because for some reason it wasn't, or you know what, I don't think I had to turn it off. If I remember right, I think I just had the low side hose off, so it was building up pressure in the system. So, or low side hose on. So I had to loosen the low side hose, so the nitrogen that I was flowing through the system had a place to exit, right? Because if you leave the hoses connected, then it's just building pressure in the system, and you're never going to get it to brace shut. So I really appreciate you guys making it to the end of this video as usual. You know, I do a lot of these R290 cooler repairs. I don't really film them as much, but it's really nothing to be afraid of, guys. Just follow basic safety practices, purge with nitrogen before you braze. You know, when possible, cut fittings out of the system, but it's not very practical on something like this, because I needed to unsweat the TXV because the copper lines aren't very long, and I didn't want to add any extra work to it. So just got to understand the potential problems and be ready for them. Always have fire extinguishers ready, and, you know, well ventilated area and all that good stuff. So if you guys haven't already, please check out my website, hvacrvideos.com. We have merchandise available. We have the this is the flag shirt right here. Got a flag on the sleeve, this one, and then it says HVACR videos on the back. We have a couple other shirt designs, sweaters, beanies, hats. That's like the #1 seller. We have women's shirts in this flag design. We have women's cut ones. So yeah, check it out, hvacrvideos.com. Other ways to support the channel, the easiest way is watch the videos from beginning to end without skipping through anything. That's the simplest way. It doesn't cost you a single thing. If you want to continue to support the channel, you can donate via PayPal. You can donate via YouTube channel memberships, Patreon, TrueTech Tools. If you want to go to truetechtools.com, you can use my offer code BIGPICTURE, one word. You'll get an 8% discount on checkout. You get to buy some tools. I get a little commission from that discount code. And then if you use my offer, if you shoot me an email, I can generate an affiliate link. I get a little bit of an extra commission from that, and you still get to use the discount code. So just let me know. I really appreciate you guys, and we will catch you on the next one, okay?